Alrighty, everybody. So today we are going to be looking at rate of change and slope of lines. So a rate of change is a ratio, and remember a ratio looks like a fraction. So it's a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So basically you're looking at two things and you're looking at how do they change together. So the way we find rate of change is we look at what is the change in y over what is the change in x. There's our ratio. Okay, and a specific type of ratio that we're going to be looking at frequently, a lot throughout this unit, is slope. Slope describes the rate of change as you move from one point to another point. So the slope is basically how do you move from one point to another on a graph. So if I look at these two graphs below, okay, if I want to calculate their slopes, describe what's going on. So you'll notice if I started from, let me get a different color, if I started from here and I wanted to go to 4, 4. So if I started at 0, 7, the y-intercept, and I wanted to go to that point of 4, 4, well, I would go down, and then I would go over. I would go down in the negative direction, and then I would go over in the positive direction. All right? So that's going to be like a negative slope, because I'm decreasing on that line. I'm going downhill. Okay? And then the one next to it, I'm going to go up in the positive direction, and then over in the positive direction. So that's a positive slope because you'll notice that's increasing. You're going uphill on that. All right? So how do I actually calculate slope? Well, if you have a graph, what you're going to do is you're going to look at rise over run. And maybe you've heard of that before. You're going to take rise over run. This right here is the change in y. Your rise, your vertical change, and your run, that's your change in x because you are going to be changing horizontally there, okay? And something you may know as well is that slope, the variable for slope is going to be m, which is going to be helpful in what we're going to do in our next video. So slope is going to be referred to with the variable m. So here I have 4 different graphs, and we're going to calculate the slopes of each of them. All right, so the first one, you pick a point, and I'm going to pick this far one, and you do the rise over run. So you'll notice you go up 2 in the positive direction, and then you go to the right, and then you just got to count. You go over 1, 2, 3, 4, 5, 6, 7, 8. You go to the right 8. So your slope is going to be your rise, which was 2, over your run, which was 8. And then you want to simplify those fractions. So your slope is going to be 1/4. So you'll notice this is a positive slope. And your positive slope is going to look like an increasing line. So positive slope, increasing line. Okay? Because if you think about, like, if you're a person on this line, and you're walking on this line, you're going uphill. If your graph is going uphill, you're going to have a positive slope. All right, so let's look at my next one now. I'm going to pick a point, and you're going to see I'm going to go down 2. I'm going to go down 2 in the negative direction this time, and I'm going to go over 1, 2, 3, 4, 5. So I'm going to go over to the right 5. So my slope is going to be the rise, which was down 2 or negative 2, and to the right 5. So down 2 over 5, my slope is negative 2/5. So this is a negative slope. You'll notice that my graph is decreasing. And if you were a person on this graph, you were walking along this line, you'd be walking downhill. Downhill. Okay? Now, you could also have a graph like 7. And in number 7, I don't know why they're numbered like that, but in number 7, you have 2 points. You're going to the right 2 2 and you have no rise. You're not going up or down at all. So for your slope, your rise is 0, your run is 2. Well, 0 divided by 2, that's going to give you 0. So your slope of this line is going to be 0. And whenever you have a 0 slope, if a slope value of 0, you're going to have a constant graph, which is also, I'm actually going to put that in parentheses. You're going to have a constant graph, which is going to be a horizontal line. A horizontal line, which is going to be constant. Okay? Now, I don't want you to confuse that with the next one. So in the next one, you'll notice you are going up 1, 2, 3, 4, 5, 6. You're going up 6, but you have no run this time. You're not going to the left or to the right at all. So you're going up 6. You have a rise of 6, but you have no run. So if you check with your calculator, you can't divide by 0. So m equals 6 divided by 0. That's going to give you an undefined slope. Okay, and if your slope is undefined, that's going to look like a vertical line. Okay? So it's very important to know what different types of slopes you are going to look at. And then also what they can, let me back up. It's very important to know what the graphs will look like and then determine what the slopes are going to look like based off of graph. You've got an uphill, you've got downhill, you've got constant, and then you have a horizontal line, and then you have a vertical line. So it's very important to know what type of slopes you'll be dealing with. Now, not every problem is going to give you the coordinates, or the graph. Sometimes it's just going to give you 2 coordinates. So if you want to find the slope based off 2 coordinates, the formula for that, so slope, remember that's m, the slope is equal to the change in y, so y2 minus y1, over x2 minus x1, okay? Or you could use slope and do y1 minus y2 over x1 minus x2. It really doesn't matter which one you use first, which point you pick first, but it's very important to see that if you start with the second y coordinate on top, you need to start with the second x coordinate on bottom. Okay? So whatever you start with, whichever coordinate you start with, needs to be the first coordinate on top and the first coordinate on the bottom. Okay? So that's going to wrap it up for this video. A lot of just notes on this one. And then over the next couple videos will be the problems where we're going to use these formulas, use this idea of slope in order to figure out or in order to calculate the slope between 2 lines.